Hi guys, today at work I ran into something like this as a complex number, and I was just wondering why the solution to this is plus or minus I. And I've never personally studied complex variables in any kind of depth or rigor. I've been introduced to them in my college career, but I never took a class on the topic. So the solution to this, if you solve it's really simple, but I was just wondering where it comes from and how to make sense of it. Because if you solve it, minus 1, then you get x squared is equal to negative 1. Take the square root, you get x is equal to plus or minus I, because the square root of negative 1 is defined as I. And I was trying to figure out how to make sense of that. So I spent some time figuring it out, and then I couldn't find a video or an image on Google search the whole 10 minutes I looked into this explaining the shape of it. So I decided to make a video explaining the shape of it. So let's totally erase that. Let's say that we have a function f of x and y, and that's equal to z squared plus 1. So f is has a two-dimensional input, x and y, where x is defined the complex number, just call c just some generic complex number, is equal to x plus yi. So x is a real component, y is the imaginary component. My light just died. That was random. So this is real and imaginary. Then z is a complex. Z is a complex number. Hold on, let me check my light. Something just happened. I don't know, my light just broke. So z's two-dimensional, complex numbers are two-dimensional, they have a real component and imaginary component. So two-dimensional number, so we're taking a two-dimensional number and squaring it. So z, the x component is x, the real component's x, the imaginary is y. So this notation I chose wasn't the best. It should be f of z is equal to z squared plus 1, which is equal to f of x, y, which equals x plus iy squared plus 1, because z is x plus iy. You square it, you get x squared plus xyi plus yi squared plus 1. You clean it up. I squared is negative 1, so it's going to be negative y squared. So you get x squared minus y squared plus 1. That's the real component. The imaginary component is x, y, I. So we have a real component here, imaginary component here. So that's what this equals. Now we want to know more about the shape. So we do f of z, but write in terms of x and y. That's equal to x squared minus y squared plus 1, x, y, I. Okay. So shape of x times y, you can figure it out. It's not too bad to do. When x is equal to y, you're basically just squaring it. So along the diagonal between x and y, it's squared, and when you're off diagonal, it's a value always less than where it peaks out along the diagonal. So graphically, I haven't studied this in any depth except just thinking about it right now. If we graphed it, it would So this is the diagonal. It'd be some shape that always peaks along the diagonal. So that would be, this is that shape. But now we want to know this shape, because we want to find the roots. Roots are at f of z equals 0. So to make this 0, just make x 0 or y 0, which is more or less to say 0 comma 0. The real component 0, the imaginary component 0. To make the imaginary component, just choose x or y equal to 0. It'll become 0. To make the real component 0, it's more work, because you choose a non-value 0 of x. Any value of x you choose plus 1 plus this component will not be 0. So it's not as easy as figuring out that. So we know how to make this part 0. We now got to figure out how to make the real part 0. So now we have x squared plus minus y squared plus 1 equals 0. X squared minus y squared plus 1 equals 0. Any value of x you choose plus 1's, any non-zero value x plus 1's not going to be 0. So I'm not going to go through this in any rigor. I'm just going to say just throw away x, just assume x equal to 0. Now we're just looking at this, minus y squared plus 1 equals 0. You can move y to that side, and then you basically get y squared is equal to 1. Take the square root of both sides. You get y is equal to plus or minus 1. So then if we go back to here, this is the imaginary component. So that says that the imaginary component is plus or minus 1. So that says the solution and is at x is 0, imaginary component plus or minus 1, which is 0 plus or minus 1 plus or minus I is what it equals to. And then you're like, but that just feels so weird. So then I wanted to graph it because that just felt weird. So this is where the cool graphical stuff comes in. If you look at this and remember back from calculus or wherever, you'll be like, oh, this, if we just think of it as z prime is equal to x squared minus y squared, that looks like a hyperbola or a paraboloid or one of those things I learned. I think it's called a hyperbolic paraboloid, or who knows. Whatever it's called, the slang term for that that's just slang for, or this is just called a saddle point. A saddle, it's not a point, it's called a saddle. So graphically, what a saddle looks like is basically a Pringles chip. So here's a Pringles chip. Eat one. You want to graph it, so you got a nice visual. I think I messed up. Oh well. So my marker dried out because I left it open. Get a different color. While it's stuck. Now, we're not working with z prime now, we're working with z. Z is equal to x squared minus y squared plus 1. What all it's doing is translating it up. So in this saddle, the origin is located right there, in the center. But when we had this one, origin is not located at the same point as the saddle. So the origin is somewhere down here. So then when we draw the axis in, this would be the real axis, this would be the imaginary, this would be the real component of the response. The imaginary component of the response, we had that picture of x and y, and we had this, it was peaking along the diagonals, and it's always 0 along one of the axes. So you get that shape. This would be the imaginary, this would be z sub I for imaginary, but we're looking at the real component, and you get basically a Pringles shape, but it's shifted up. And so you have zeros right here because it's sort of, I don't know, bending downwards. So that's where that comes from. So then this says that the real component for the root must be either at this location or that. This says the real component for the root has to be along x equals 0 or y equals 0 because there's 0 along here. So this says it has to be along x equals 0. So it has to be along this axis, not that axis. And then that eventually leads to the solution of the root at 0 plus or minus I. Voila! I hope that was helpful. Bye.